thanks for being here. And okay, perfect. So this is me, I'm Bave. I'm a creative director in Big Blue Studios, as you can see. And today I'm going to try to convince you why you need to pay more attention of design and how to be able to improve it in terms of your project. Just a brief question for you. How many of you are into game design or level design? Please raise your hands. Okay. How many producers or product managers? Okay. Half of you will love me. The other half, not so much. So, a bit about me. What have I been doing? I started getting into computer games in the 80s. As you can see, that thing over here is an actual computer for the younger of you. I started on that, on DOS. Later, I went into writing. So I made a few books which are choose-your-own adventure games. I'm not sure if they were popular in Romania. Followed by the first national role-playing games in Bulgaria. Then, after my military service, I was fortunate to be hired by Hemimont, and I worked on some strategy games, the top row. Afterwards, Ubisoft Sofia, where I jumped to games for little girls, which was a surprising development. Later, I went to Ghost Recon, Assassin's Creed. I've been on 3 of those, including Liberation. And last but not least, Imperia Online, a free-to-play browser-based game. So why is this important? Well, because it gave me a lot of insight for the different genres and the different types of platforms and the different practices among these projects. And that said, I'm going to talk about something called molecular design. So, what is molecular design? Well, it's a very simple process which breaks down design to the very smallest element. And using these elements, which are based on player skill. Now, player skill is the skill that the player has versus the skill that the character has. Using these elements, you make your game mechanics. Using these game mechanics, you make the building blocks of your game, which are the level design elements. And using the level design elements, you make the blueprint of your entire game. So far, so clear, I hope, I guess, but not quite. So, some practical examples. Some of you might be familiar with this game. How many of you have played it? Oh dear. So, what is this game? It's a single input game, fun to play. Actually, it has 4 elements in it. In terms of mechanics, you have your time to react, how fast you must react in order to succeed. You have the target size, what you must achieve, its position, and you have the forecast period. So you must know what will happen in order for you to react. So you've played this game. Is it fun? Yes, it is fun. But what you see now is actually only the surface layer. In terms of game design, this is what you're playing. You have something moving at a certain speed, and you must hit certain other objects. So you see the holes are actually the objects you must hit in order to progress forward. And the amount of objects you see on the screen are those which you have an ability to forecast. Moving on to another example, how many of you are familiar with this game? Nice. So here, what do? You solve puzzles. What is a puzzle? Well, it's a question. So in every scene, you have a number of questions. And every question has a number of answers. And as is logical, every question has how many correct answers you have in order to complete it. So going back to the previous example, removing the graphics and anything else, this is what you're playing. You have 4 places to interact. You have a number of choices, and some of these choices are correct, as in example 1, most of them are correct, and in example 4, most of them are incorrect. So that is your difficulty, that is your building block if you are to make such a game. And last but not least, you all are familiar with these types of games. They're fun, they're challenging. However, there is something that you have to take into consideration. Now, what do we see here? Well, you have an object you must hit, which is in the center. It's determined by size and target position. Now, target size is determined by how close the object is to the player, to the camera. Logical. Target position is how is it placed according, again, to the main view. If it's on the side, it will be more difficult. And apart from that, you also have your time to react, which means how quick you have to be before it shoots you. You have the number of instances, translated to game terms. This is the character's health. And lastly, you have the error tolerance, which is your health, meaning how many times he can shoot you before the game is over. So, having all this in mind, any guesses of what the next slide would be, going from the previous examples? Well, I'll show you. Congratulations for everyone who plays such games. You are actually playing, you're moving a small point towards a square and pressing a button. That is everything FPS is, simplified. So I hope you're able to forget that next time you play, but from the same point, this is it. Nothing to it. And now, why is this so important? So far I've explained a bit about the molecular method, but why use it at all? Well, because it has all in one. As I mentioned, you get your design elements based on the player skills, you make your mechanics, you create your elements, and you create your blueprint, which in fact is the design for the entire game. Why is this important? I'll show you the benefits in a minute, but the main reason is it saves a lot of time and makes things much more understandable. And if you have all these tools or practices in one place, it would be much easier than using the standard design tools, which are, as you all know, Word, Excel, PowerPoint. That is what designers do, unfortunately, and it is my belief and practice that the design discipline can go a bit beyond that. We have reached this level. So here are some mock-ups of a tool that is being currently developed in Big Blue to address these problems. Now, this is the atomic table. Like, you remember how in the previous examples I spoke about time to react, number of questions, number of answers, all of those. Going through the games I've worked on and the different genres of games I've played for about 5 years now, I've been collecting elements which could be used in all types of games. Why? So I can create something of like this table in order to help people to make any game they want. And of course, since this is early stages still, there'll be a lot added, a lot removed, you know the process. But once this exists, inside you can set the difficulty of every element. So once you know what your game mechanics are, you can set their difficulty. And we have the standard 5 cases. Are you guys familiar with the rational game design methods? Please raise your hands if you are. Oh, nice. So this is highly based on that, because it's a very simple method. Several companies use it. Ubisoft uses, Warcraft uses it, Naughty Dog as well, as far as I know, and there are others. Why? Because it's efficient, and that's the only thing that matters when making games on a budget. Based on this, you can create your level design elements, and this is one example. I'm not sure if you can see, yep, you see a small square in the lower corner. That is the difficulty. Let me go back here. Here it's in the upper corner. So when you input the values of each of these parameters, you automatically know the difficulty. And this difficulty can be seen with the thumbnail and the mechanics of the element. You can see the difficulty related to that mechanic. So if you make something that shoots, it's difficulty 5, for example, in terms of shooting. If you want it to be a physical challenge, like a blocking navigation, it will have an additional difficulty in terms of navigation. And this way, when you create your elements, you can put as many mechanics as you need. And why is this important? Because here, and I'm sure you're all familiar with this, you can make the game blueprint, usually done in Excel. So the game blueprint, again, this is a mock-up of the prototype still being built. The idea is that you can drag and drop all level design elements in your specific level. On the left, you can see the temporal, is it the left? Okay. Above me here, since I don't know if it's mirrored, is the level in terms of progression and difficulty. So this is your game based on time. There is the game based on space. And like the TARDIS in Doctor Who, it's much more bigger on the inside than it looks here. So once you create your elements based on your mechanics, you drag and drop them, and you can instantly see a number of things. One, where each element is based on your temporal progression and based on your spatial progression. Why is this good? Because you can very easily change the position from one level to the other. And afterwards, you can also check where it is. So for example, midway in the project, you want to remove a mechanic. It happens. And you want to be sure what the effect will be. Could you afford it? Or do you have to find a way to use it? But here you can see, like the second line, there's mechanic 2. If you remove this mechanic, you will instantly see which levels will be affected, and following that, which elements will be affected. So you might need to compensate, or you can decide that it's too much of a risk or too much of a cost. It's entirely your decision. And also, based on this, you will have to change your spatial part of the game, saying if you remove these elements and you see part of them disappear, you have to rearrange it on the in the level so as to make sense, and not to have players suddenly walk through an empty corridor because you forgot that now it's empty after you removed a certain mechanic. Again, what does this do? It saves time, because what you can learn in playtesting, with this you can learn instantly in a matter of minutes. Going back to our previous examples, here are the actual 4 elements which compose the level design elements, the molecule of going through the, words escape me today, going through the opening. So with all these 4 elements, you can make a various game design, level design objects which you can place accordingly to the difficulty. For example, the first one is fairly easy. The player just needs to press the button to move slightly up. Between the second and the third, the distance is also minimal. The player doesn't have to do anything. However, between the first and the second, it's of greater difficulty. So in this case, we have, using the same mechanics, 2 level design elements. Going again to this, you have number of questions, number of answers, and right-wrong ratio. Again, depending on how difficult you want your puzzle to be. You can have a single question with 1 answer and it's always correct, or you can have 2 linked questions with 5 answers each, and with only 1 of those answers to be correct. It's entirely based on you to determine your difficulty, which you can do, bless you, quite well. And finally, this one, I went into detail before, but here you can determine how fast it moves. Is it further away? Does it always move to the side? These are all things you can determine once you have a template of your basic game design elements. You can easily change certain values and make elements easier or less or more difficult. Again, because I've done this in a matter of minutes, instead of thinking all day, how could I make another enemy which is more difficult than this one? And again, since all this you see is purely game design, don't worry about graphics. There could be two enemies which look absolutely different, but they follow the exact same game design parameters, such as this. And again, I hear you ask, okay, we understand this more or less, we want to use it, but what are the actual benefits? Because if you're going to invest in such a tool or practice, either in terms of money or time, you have to have a reason. Well, I'll give you 10. First, this is a single source of information. And as you all know, the more sources of information, the more problems that exist. Because one person can say, okay, look at this document, you see this is described very thoroughly, what you have to do, but at the same time, there's another source which says something which is quite the opposite. So what do? Do you follow document A or document B? You have to ask someone. That takes time. That person might not be sure. He might have to ask someone else. That takes even more time. So there could be cases in which you lose about days up to a week, which has occurred to me once, just to find out which of the sources is correct. Here, everything is in one place, so that issue is solved pretty quick. Another thing is that this requires minimal explanation. I explain to you now, hopefully in a good enough fashion, what a design is of a specific element. If you are into this, you can take in anyone from your team, explain it just by showing the blueprint, and tell them, okay, this does this, these are the mechanics, these are the elements, and is where they appear in the level and when. Should be about 1 hour at most to have anyone go to your project and get in touch with what it's about, no more. And of course, the usual benefit, because since you've already made your blueprint and you know when a new mechanic or element appears, you already have your tutorial made. And that's quite important because for all who have had the experience to have to make a tutorial to an existing game, it could be a bit of a hassle, especially if you have to do it before alpha, which has occurred on occasion. This method, and two respectively, is also great for monitoring because, again, you can make it in about a week and you can show this to everyone, including management, and say, this is our plan, we want to have these mechanics, we want to have these game elements, and based on that, they'll take this amount of time. Why? Because you know that everything is already planned, you know what's involved, and you can make an estimate on manpower and time required. Also, you can have perfect visibility. This is our plan, this is our blueprint, we were supposed to be up to level 3, but we're missing this mechanic, this element. Why is that? Do we need more designers? Do we need more artists? Is it a problem in programming? Is it something else entirely? Whatever the case, you could see very clearly and very early. Because if you watch this every week, and 2 weeks in a row there's a problem in one area, you know that you have to invest there in whatever way is appropriate. More time, overtime, more people, more effort, or cut the thing entirely. Also, using the planning and the visibility, this is great for early testing because you know what is expected, you know where you're currently at, and you can give this even during an early phase to your testers and tell them, okay, this is what we have, this is what we expect. You will not see this enemy, so go ahead and tell us if what already is already there is suitable. And the favorite part for everyone in a producer role, this saves a lot of money. Why? Because in my personal experience, this diminishes game design work by 80% in terms of time. So just think of it, something that usually took 1 week, I was managed to do in a day, which is quite significant by any standard. Also, it's very cheap to change. As you saw, drag and drop, or in Excel, add a new slide, delete and paste, cut and paste, and what you have, a new design which you could follow instantly. You don't need to, you need to play the game, of course, because this is theoretical and there's a difference between theory and practice, but in effect, you can change it very fast, and as you all know, paper is the cheapest thing ever. And last but not, okay, now number 9, no, there's one more. It's extremely easy to share, because now think of this as a term, as a tool or method for multiple designers to be able to work at the same time. So I make something, I share it with someone else on another team, on another continent, and they can know what's going on. I don't need to send 10 documents and say, figure it out. Here they see instantly what's done, and they can make adjustments and show me what's done. And finally, this is a great way to be used in other projects. You finish one project, you say, okay, I want to keep this mechanic to the next game. You can take it directly. You take the entire molecule and you reuse it as it is, because you have seen it proven, you have an idea of what the results will be, and you can reuse it without even testing at times. And now, finally, a quick review of the production cycle you all know and love. You have a brainstorm, which is short, conception, pre-production, during which time we all know that all the features are done and locked, of course. You have production, and final, a bit of polish to fix the bugs. But nothing major, as we all know, happens all the time, wink. So, using this blueprint, you can develop it even in the brainstorming stage, because it's cheap. You can make as many as you need until you have one which you like. Focusing on that one, you can make your prototype, your proof of concept, and you can share the vision you already have chosen. You've chosen the best mechanics of your game, you've showed it to the key stakeholders, they say, okay, make the full one. You have already made the full one, because at this point you know what will happen till the end of the game. You start making your lists, how many people we need to hire, how much art is involved, how much time, what programming, what assets, etc. And you can also start prototype testing. What do I mean by that? Since this is pure game design, you can test it on a cheaper engine which is already done, if you're using your own much more complicated engine which is not complete yet. Following that, you have locked the blueprint, only the producer can change it, you are just making elements and tweaking things where necessary, because tests have shown that you have done something wrong. And finally, during the polish stage, you can monitor it. The testing department knows exactly what to test and when to test. And why have I put brainstorming here at the end? Because this could be a starting point for your next project. Based on your discoveries and the mechanics you like, you can transfer directly to that. And since I'm running a bit out of time, thank you, and I'll be glad to hear if you have any questions.
Hi, Bave. Thank you for this presentation. I'm familiar with rational game design. I was wondering if there are some differences with the method you present, or is it another terminology, another vocabulary to speak about the same thing?
Well, since in Ubisoft I was an RGD trainer, I developed this based on the RGD. Okay. And it's pretty much quite similar, but there are certain things which during development I've decided to change and make a bit different. So think of it like RGD Plus, or developed afterwards. And there are other things which developing the tool will be involved, like the loops are not present here, sharing through Trello, exporting, so that instead of writing reports, you can give this directly to mail, again, to save time. The idea is RGD was very theoretical. I want to make a design tool which is like Maya for game design. And this is the goal of Big Blue as well. So having such a tool, you can make things, again, faster and much, much more practical. RGD, its only problem was it was a bit too theoretical.